Looking at the last of the exceptional cases in terms of y equals ax plus b, and what I want to show you for this particular line is they've just kind of algebraically manipulated the x and the y to kind of hide the form of y is equal to ax plus b. And being able to isolate y in this equation is really important. It's going to be a skill we use later. So I'm just going to take a second. I'm going to write out 4x plus 0.5y is equal to 20. And what I'm going to do now is I'm going to begin isolating that y. I want, at the end of the day, this thing to be in y is equal to ax plus b form. So I've got to do two things. The 20 is already on the right-hand side of the equal sign. It's not bothering me over there. But I've got this 4x, remember this is all one number, being added to my y. And I have this 0.5 being multiplied to my y. So I got to get rid of those two numbers and their associated operations. The way I'm going to do that, I'm going to subtract that 4x. It's being added to my y, so I'm going to do a subtraction, and I have to do that from both sides. That's going to leave me with 0.5y is equal to negative 4x. Don't forget your x plus 20. Now, you can't simplify these two. That 4x and that 20 are not like terms. They have to stay as is. Last step is divide everything by 0.5. Right, to get rid of that multiplication, we're going to do division, opposite operations. That's going to leave me with y is equal to, now I'm going to do that division there. Negative 4 divided by 0.5 is going to be equal to negative 8. X, don't forget your x, plus 20 divided by 0.5 is 40, but just to make sure. There it is. 40. And now the equation is in y equals ax plus b. And you can see it really clearly. Generally speaking, you got to get rid of the x term, and then you got to get rid of the coefficient of y when it's set up like this. Right? So just to recap, subtracted 4x from both sides, and then divided by 0.5, or the coefficient of whatever the y is. If that's a 2, you divide by 2. If it's a 10, you divide by 10, etc., etc.